Yes, I'm all ears.
What is the switch block doing?
The switch block is giving an initial value to the VPV so it doesn't get 0. Because the 0 is divided by a number, it will give infinity. So it's purely like, I put it here purely for reasons of avoiding a 0, giving an infinite division. So, let's do this.
So the step block steps from 0 to a non-zero value.
Yes, that's what I'm trying to. Oh, okay. Wait, did it work? Yep, we passed it. Okay, the saturation should be here. All right, let's see now. Maybe that was the mistake. That I didn't saturate the control of the. Okay, now it is down here, which means that it is trying to find a new value. Let's see what's happening down here. Okay, the step should get through eventually. We should go towards the upper voltages. No, you don't like it? Is the power already so fast up to the value it should be? Let me see. Oh, actually it is. Huh, interesting. And it's actually more. Okay. So, oh, not my smartest realization here, because this will not create a ratio that will show the effect of the voltage, and that's why we have this trouble most often. Let's check again. Past the 5 seconds. Ooh, perfect. Okay, now we should be right. Yeah, now it goes towards the right voltage. Alright, it's climbing, it's climbing. Let's check the power. Let's check the power. We wanted to go all the way to 1800. It went past that, of course it did, because to properly model this part, I need to also give it a negative value when it goes past the nominal. So let me do that too, so I can cause the perturbed observer to go back. So, how am I going to do that? So this is going to give me a plus, and yes. All right. Okay, and now it's going to be this thing going here. Shush. All right. Okay. Okay. Of course, this is going to be here. So criterion for threshold 1. So. If this becomes 1 past the first input, so if it is less than 1, you use the same input. And for the other input, it's going to be now the inverse, because I was thinking of the other thing. So now we're doing it this way. Okay.
Both of the two switches are have threshold to 1.
Yes.
Okay.
Let's see. Okay. Okay, start dropping. How much to drop? At 1800. Okay, not yet. Let's see the power. The power should be decreasing a bit. But what did I set it at? 17 kilos, okay. Oh, there we are. Now it's working. Okay. There we are. There we are. Okay, so I modeled it. So what is happening here? What is happening is that the perturber observed started with some voltage imposed on the terminals of this string of modules in order to try and find the peak. Now, as I said in the model that I showed you, here in the photovoltaic string, I didn't implement this full PV curve. I did a patch just to show you that once I hit my ideal peak voltage, I should make the string lose power, okay, so that it goes on this side. If you would have to model the full photovoltaic module with full detail, you would have to use the photovoltaic phenomenon here through the PV curve. For the sake of simplicity, I created a simple trick that said, if the voltage of the string is below 1800, allow this string to give it its maximum 17 kilowatts and whatever time it is. Once it exceeds the 1800 volts, let it reduce the power from 17 kilowatts, whatever the time of the day is. So what happened is, the control of the perturber observed started at a certain voltage, it increased, and once it hit the 1800 volts, it stopped. But actually, it didn't really stop. What happened is that it does little steps up and down, checking and confirming that the power hasn't changed. So what you see here is that the perturber observed this little control block here is trying to find the ideal voltage that is going to be extracting the maximum power out of the photovoltaic. Okay? So if we let it run for the whole time, which again it might be a little bit tough, you see here, for example, that we are slowly but steadily approaching the peak of the 17 kilowatts. Okay? Or the fact that the power has not peaked yet and it's going to find the ideal power in a bit. So I showed you earlier that at 3 p.m. I don't want to break it now, so let it run. And it should get at about 16 something kilowatts and then it should start dropping. It's still running, right? I didn't stop it. Yeah, it's still running, it's down here. Let me show it to you too.
We can change that.
You see that? It's still running, okay? So you see that the power keeps increasing until it's going to find the ideal power around that voltage. Okay? So this is what we're seeing here. The operation of the perturber observed. The main point that I want to make, as I told you earlier, is this. That the perturber observed keeps increasing and decreasing the voltage at several steps per second to see if the power is going to increase or decrease. And let's go to the power to see how it looks up close. Let's go here and see what's happening. You see? Up and down, up and down, up and down. Okay? So it is still adjusting. Okay? So this is how the perturber observed practically works. it plays with the voltage of the string of modules until it hits the right voltage that it imposes at the terminals of this string, which ensures that the power is going to keep increasing. But it never stops going up and down in little steps around the peak operating voltage. Questions?